the row. It's kind of similar to what an exam question could look like. So it's worth perhaps knowing how to do these things. And it really has two parts in this lecture, really two parts. And the first part is you should work out Tableau without pivoting from what you're given. So in this case, it's perhaps a little bit silly, but it's just trying to demonstrate the method in which you can get any Tableau without pivoting. You know the final basis, or if you know this inverse matrix and the inverse. If you don't know it, then you have to find the inverse matrix. But now you're given the inverse matrix, so the rest of it you can calculate quite easily. How does it go? Okay, well, the val, well, each of these columns really over here is a linear combination of these two columns, and the numbers that you have to take for the multiples of the columns are, they come from here, from the original formulation. So if you want the right-hand side, you use 10 and 15, so you get 10 times 1 minus 15 times 1/2. So that's 10 minus 7.5, so that's 2.5. Okay, and here you get 10 times 0 plus 15 times 1/2, so it's 15 over 2. All right. And for x1, well, you use 1 and 2, so you get 1 minus 1 is 0, and 1 times 0 plus 0 times 1/2 is 0. Well, oh, sorry, what am I doing? 1 times 0 plus 2 times 1/2 is 1, so you get a 1. Well, which you knew anyway, because x1 is in the basis, so you didn't even have to do anything, really, because you know that this column has to look like this. And for x2, you use 2 and 4, so 2 times 1 minus 4 times 1/2 is 0, 2 minus 2, 4 and 2 times 0 plus 4 times 1/2 is 2. And then you use 2 and 3 for the last one, so 2 minus 3/2 is 1/2. And 0 plus 3/2 is 3/2. Okay. How about the objective row? Well, the objective row you can kind of do in several ways, but the way that I want to look at now is, in fact, the objective row is, you have to take multiples of these two rows. And what multiples? Well, the multiples are given by this original objective function. So the bottom row is x1, and there's 3x1 in the objective, so you'll be taking 3 times this row. And the top one is s1, and there's no s1 in the objective, so you'll be taking 0 times this row. Okay, so you take 0 times this row and 3 times this row, and that kind of works. Well, it definitely works here, so 3 times 7.5 is 22. But here, the way it doesn't quite work is decision variable columns, because there you do take 3 times this row, but you have to subtract the original 3, 5, and 2. So you will get 3 times 1 minus 3. You will have 3 times 2 minus 5. You will have 3 times 3 over 2 minus 2. And that gives you the answer. So the answer is now 1 and 5 over 2. And the optimal solution is x1 is 7.5 and x2 and x3 are not, and the objective is 22.5. Okay, so that's how you and then when you want to do adding, when you want to add a constraint, so adding a constraint is something that we did last week. So these parts over here and all the way there, and this objective row, that is exactly what you have up there. So that's just copied. But the new row, you look at the new tableau, the new constraint, and it has 6 in here, and it has 3, 1, and 2, and this is associated with the new slack variable. So we get something like this. Now there is a problem that, as we said last week, we need. So S1 was 1, 0, 0. Okay, that one is not a problem. But for the basic variables, S1 is okay, S3 is okay, but for X1, we want a 0 there. So what we need to do is subtract 3 times this row from that row to get new tableau, which is really a tableau. So just going to put in the values, 7.5 to 3 over 2, 1/2. So 3 times these values, I'm taking away from the S3 row to get 0 where I want it. Okay. Now what's going to happen is the new S3 row is going to be minus 16.5, 0, minus 5, minus 5 over 2, 0, minus 3 over 2, and 1. And this was 22.5, 0, 1, 5 over 2, 0, 3 over 2, and 0. Why do I need the objective row?
To find the ratios.
Yes, I'm going to want to find some ratios. So what I need to do now, because of the negative value in the val, is I need to look at the negative entries in this row and pick one of them as the dual pivot step. And for this, I need the ratios. So the ratios are 1 over 5 and 1 and 1. And I want the least one, which means that this negative 5 is my new pivot element, which means that S3 is replaced by X2, X1 and S1 stay. And what I get, it looks like this: 3.301, 1/2, 0, 3 over 10, minus 1/5. That's the new pivot row, just divided by minus 5. And the rest I'm just going to write. It's the usual pivot step. So this would give me a new optimal solution, which is X1 is 0.9, X2 is 3.3, X3 is still 0, and the objective is now 19.2. Any questions? I think it's worth about like 3 homework marks. First tableau, then added the constraint, and then the dual pivot. Thank you. This is correct.
I got everything correct except the very last objective row. But that was just bad maths.
All right, okay. So you think that's right?
Yeah.
Okay, good. Might be that I made a mistake.
No.
That's good to,
22.5,
good to check.
3.3 is definitely 19.2.
Okay,
I've got 17.
good. Right, so that's the homework. Now, the task for today, when we look at basically that we already know how to do. Adding a new decision variable we already know how to do. Adding a new constraint we already know how to do. The next thing on the list is when we start changing the objective function, what's going to happen. And when you look at the matrix, and was also, well, yeah, when you look at the matrix, and was something that we were, Tableau really, something that we were doing at the start was what was it? So we were kind of, you remember the first thing we did, the first tableau, we were calculating the objective row from the rest of the tableau, okay? And there was a bit of a more influence of a basic variable because with the basic variables, you needed to times the rows of the tableau and add them together by their C coefficients. And the non-basic variables, they only did one thing, and that was they got subtracted here, okay, in their own column. So the difference when you're changing something in the coefficients in the objective function is whether you're doing it with a basic variable or a non-basic variable. Okay? So when you're doing it with a non-basic variable, that just said, the only thing that's going to happen really is it's changing x3, say, and x3 is not in the basis, then only the x3 entry is going to change. Whereas if you're doing with something with a basic variable, then it's going to change a bit more. But again, the only thing that is actually going to change is the objective row because the C's don't appear. There's no influence of the objective function on the top bit of the tablet. All right, let's. So we have an example here. Which is this LP. We're told what the problem is, and we also have, which is coming right now, we also have the tableau. And now the first task is, it says here, that we're changing C1 from 3 to 8. So this 3 is now going to be 8. What's going to happen in the final tableau? An interesting question. So as we know, it's actually quite easy. Does anybody know what's going to happen? So how did we get the footnote? You were given just this top bit of the tableau, and you wanted to know the objective row. Now, without changing 3 to 8, what you did was, we did just a while ago, was 2 times this row, okay, 5 times this row, because of the 2 and 5 here, and 0 times third row, because there's no s in the objective. Added them together for this. When we did that, we had to take away 3, because there's 3 x 1. So now instead of doing something take away 3, we'll be doing something take away 8, which means this is going to go down by 5, isn't it? So the only thing that's really going to change is this is going to be -1. Yeah, the coefficient increased by 5 in the objective, so corresponding entry decreases by 5 in the tableau. This is because x1 is not in the basis, so that's really simple. There's only one thing that changes in the whole tableau. Okay? So everything else stays the same. I'm not going to copy everything, but we might need some of these things. But the only thing that's left is what? Joe's the only person willing to
Got a negative objective variable what is swap. So what I got there.
Yeah. Well, the negative means the tableau is now not optimal or not dual feasible, if you like. So you want to pivot. Which one? Well, ratio test. Right? So this ratio is 10. This ratio is more than 100. Whatever it is, it's definitely more than 10. So this is the new pivot step. A new pivot element, rather. Now on the next page, doing a pivot step is probably boring, so this is the thing that's left as homework. And then you'll get the new optimal solution. Now there's like a very kind of interesting thing to mention, and we'll come back to it again. But what's that interesting thing? So this 4 that gives you some information, doesn't it? In particular, it gives you information about how much you would have to change the coefficient of x1 in the objective in order to have to pivot. Okay. Well, we changed it by 5, so we went from 3 to 8. Changing it by 5 meant this went down by 5, so it became negative. Well, if we only changed it to, say, 6, so increased by 3, then this would be 1, 4 minus 3. So nothing would really change. The only thing in the whole tableau that would change would be this entry. That's it. So in this sense, this 4 is giving you some information about how much more profitable x1 would have to become for it to enter the basis. So if you think of this in terms of like having 3 products. So, and these are some constraints and some resources. And these are the profits of the 3 products. And this 4 is giving you an information about what currently you're not making. In the optimal solution, you're not making any of the product that X1 is there for. And so this 4 is telling you that if the profit on a unit of the first product increased by at least 4, then perhaps it would make sense to start producing some of it. And this kind of interpretation is called the shadow. No, not the shadow price. What's it called? I forget what it's called. It's called the reduced cost of that. So, well, anyway, so just as a remark, the obj row entry in the X1 column tells us by how much the coefficient of X1 in the objective function would have to increase for X1 to enter the basis. So it's like, think of increasing the profit of product 1, something like this. Okay. It's not in the basis, you're not making any of it, because the profit on it is just not large enough. But if you increased it by at least 4 per unit, then it makes sense to start making it. So that's for the non-basic variable. Is that clear? No, more or less. Keep copying. I'll cover it soon. Okay, so now the next thing that we have, part B. This is telling us to forget what we've just done with C1. C1 is 3 again, but what we want to change is C3 from 5 to 3. Okay, so C3 from 5 to 3. Now, the third product is a bit less profitable, so it might happen that we stop making it, but we need to work that out. Right, so again, the only thing that's going to change is the objective row. So I don't even need to do much about it. Yes. So this part stays the same. I'll just put them there, just in case we need them. Right, so now we're changing C3 by -2. So where we were taking 5 times this row, plus something, minus something, to get the objective row, now we will only be taking 3 times this row. Okay? Which means that we take 2 times this row, and take it away from this objective row, with the exception of this entry. That is what the new objective row is going to be. That make sense? Well, whether it makes sense or not, doesn't matter. That's what it is. So this entry, what was it? It was 350, and we need to take away 2 times 230. So that is 890. Okay. This entry, what was it? It was 4. Now we're taking away 2 times 3/2. So that is 1. X2, we're taking away 0, so it just remains 0. X3, I'll skip. S1, we're taking away 0, so it remains 1. Here we're taking away 1, so 2 becomes 1. And here we're taking away nothing, so it stays 0. And the X3 column, well, that you probably knew that it would always have to be 0. Okay. So this also makes sense because what we actually, this X3 entry, well, we took 5 times this, but then we subtracted 5 to get to 0. Now, what we're doing is we're taking 3 times this, and we need to subtract 3, so it changes on so it stays 0. To the basis, it has to. Well, because we still have everything non-negative in the objective row, no need to pivot, so the new tableau remains optimal. It's just changed some of these, reduced some of this. Shadow prices, the resources have changed, and the reduced cost of X1 has changed, but and of course because well, the profit went down of the third product, well, the total objective went down as well in the optimal solution, but it still remains the same basis as optimal. Any questions about that? No, I need to find my notes for the next thing. Ah, there it is. Okay. Next thing on here, part C, it's a bit different. So now it's not telling us how much the coefficient of X2 is going to change. What it's telling us is we should work out what the possible changes in that coefficient are for which the current basis is still optimal. So that was the easy thing, which we said about the non-basic variables. The non-basic variables, you just look at the entry in the objective row, that was 4 in x1, and we knew that if we changed the coefficient by more than 4, basis would cease to be optimal. Okay? So for x2, because x2 is a basic variable, that's not so simple, but it's not very hard either. So so suppose that C2 changes to, well, C2 was 2 in the original LP, and the new C2, let's say it's going to be 2 plus delta. Okay, delta is the change, the Greek letter for changing stuff. You probably know that. And so what happens? Well, we know what's going to happen. Namely, we know that as always, the top part of the tableau does not change at all. I'll put it there just to see what it actually is. 0 minus 2. Okay, this is what tableau was before we did anything. But now again, I want to go back to the thought that was there. So I'm resetting, not considering, forgotten again that I wanted to change C1. C1 is back to what it was. So we're starting with the original formulation. And it's just like it was. So what we were doing is, because C3, when it decreased by 2, we took minus 2 times this row, added to the objective. And now if it increases by delta, we take delta times the x2 row and add it to, and that's constant. What do I want to add it to? Okay, so if I'm adding delta times that row, what I'm going to get in the objective here is this plus 100 times delta. Now here we have 4 minus delta over 4. Well, x2 we said that's not going to change because x2 is in basis and is the one that we're doing. And this is, we're adding delta times 0, so that's 0. This one is 1 plus delta over 2. This one is 2 minus delta over 4. And this one stays 0. So what kind of delta is not going to make us have to pivot? How do we know whether we'll have to pivot or whether the basis is still good enough, meaning optimal?
Objective goes always going positive, so just whatever delta keeps the objective positive.
Non-negative, yeah. But yeah. So all these numbers will have to stay non-negative. And if it does, then we don't have to do anything. That gives us really three inequalities because all the zeros are non-negative. But what we want is 4 take away delta over 4 has to be greater than or equal to 0. The second one is 1 plus delta over 2 has to be greater than or equal to 0. And 2 minus delta over 4 to be greater than or equal to 0. Okay? Now, if you solve them for delta, first one is equivalent to saying delta is less than or equal to, well, 16. This one is the same as saying that delta is greater than or equal to 2. And the last one is the same as saying that delta is less than or equal to 8. Now, all these inequalities have to be satisfied, right? So this means that the current basis is optimal when this delta satisfies all these inequalities. So in particular, it has to be less than or equal to 8 and greater than or equal to 2. Right? The 16 also less than or equal to 16, but when it's less than or equal to 8, it's already satisfied. So if you wanted to know what that means for the original C2, well, C2 is 2 plus delta, so C2 will have to be between 4 and 10. No. Yes. What have I done? I've done something wrong. I have indeed. Can anybody spot that? This should be minus 2. Delta over 2 is greater than or equal to minus 1. Delta is greater than or equal to minus 2. That was wrong. So I want minus 2 here. And because of the minus 2, it's no longer 4, it's 0. Okay. Better. Any questions about this? It's kind of straightforward. Now, so this we know how to do. This we know how to do. This we know how to do. This we now know how to do. Out of 6, we already know how to do C. B we don't know yet, really. That's something that remains. Changing something in the actual coefficients in the constraints, we still haven't covered. What did I mean by this? Well, the dependence of the objective on changes in B we did because that was the shadow crisis, so we know that. The dual variables give us some kind of information about how the objective function in the optimal solution is going to change if we start changing the what constraints. So most of it we already know. There are a few bits left, which we should probably finish next week. From this week, one of the tableaus was not completed, so that's the homework problem. There are no more questions, and that's it for today.